Greetings everybody. I'm going to start out today by sharing a presentation for manuscript titled Microclimate and Irrigation Requirements under Greenhouses in Egypt. The authors of the manuscript are Muhammad Abdurabbu, work for Agricultural Research Center in Egypt, and Dr. Akbar Javedi, Department of Engineering, University of Exeter, United Kingdom, and Dr. Abdelazim Nib, work for Department of Engineering, University of Zagazig University. The aim of the current study is to illustrate some of management practice in terms of microclimate under different greenhouse covers and irrigation requirements and the common crops under greenhouse in Egypt. The greenhouse in Egypt is important for a continuous supply of vegetables for local market, especially during the off-season. The grower obtain more production from water, fertilizer, and the land units under the greenhouses. Greenhouses have become more important for food security with the rapid increase of popularity in Egypt. Material and the methods. The first of all, I will talk about the dominated climate in Egypt. The climate in Egypt is very characterized by a dry summer season associated with low precipitation and high temperature, and a winter season with light rain. Rainfall gradually decreases with altitude from the north to the south. The lowest maximum and the minimum air temperature occur during December and January. Temperature gradually increases from February to reach the highest average temperature during June and July. Managing the microclimate and the irrigation system in the greenhouse is considered a major challenge faced by growers due to the differences of cover climate, polyethylene, screen, and shade nets. Evapotranspiration follows almost the same trend as air temperature. Air relative humidity increases during January to reach about 70%, and decreases from April to about 50%, and then increases again during August until December. Climatic data. The climatic data was collected from automated stations belonging to the Central Laboratory for Agricultural Climate. The greenhouse's dimension were 40% length, 9% width, and 3.5 meters height. The air temperature and the relative humidity under the greenhouses were measured by digital thermohydrograph. The irrigation requirements was calculated according to FAO 56 method. The main results in this paper. Data in the figure 1 shows the air temperature and under different cover materials such as polyethylene, white and black nets compared to open field condition. The temperature and white net cover was slightly higher than open field during the daytime, while the air temperature under the shade net was lower by 2% than the open field. Polyethylene cover increased the air temperature and the relative humidity compared to the screen net cover as well as open field. Greenhouse design in Egypt should deal with the high daytime temperature during the early summer, especially with high frequency of heat waves in the last 10 years. This data can help the growers and investors to select the proper cover for concerned crop according to the environmental need for each cultivated crop. Greenhouse structure covered by screen net or shade net are considered one of the convenient practices to be adopted, especially during the summer season. Lower air temperature under shade net depends on the darkness factor of the screen material. Shading nets applied will be effective in relieving the heat load of the greenhouses and then reduce heat stress for cultivated crops. However, using proper screen net allows effective ventilation to permit sufficient airflow through screen opening. The effect of the screen net is to reduce heat stress for plants during summer season due to lower air temperature and avoid direct exposure to solar radiation. The irrigation management under greenhouses. Data presented in the table shows the irrigation requirements for major crops during the cultivated season in Duke area Giza government. The irrigation requirements start with a small volume, small quantity during the early season and increase after that in the mid and maturity stage. The irrigation water requirement increase with increasing air temperature and then evapotranspiration. The impact of the greenhouse cover on air temperature led to direct impact of crop water requirements. Evapotranspiration follows particularly a similar pattern as air temperature. The climatic data and soil moisture was measured by proper sensors to estimate the irrigation requirements and the climatic data under the greenhouse, different covers of greenhouse. Common crops in Egypt. The greenhouse expanded significantly in the last few years in Egypt, which led to increase the local production of some vegetable crops such as cucumber, pepper, tomato, and green beans. The high production led to decrease in the price of the produced crop with higher competition. Some growers started to cultivate tropical fruits such as mango, orange, and banana to obtain significantly high income from land and water units. More crops should be adopted under the greenhouse, such as medicinal and ornamental crops such as basil and cut flowers. The conclusion, the current work demonstrated some of management practices in terms of microclimate under different greenhouse cover, irrigation water requirements, and common crop under greenhouses in Egypt. Increase in temperature during summer season led to increase the irrigation water requirement due to increase the evapotranspiration value during hot day time, which increased with increasing temperature under the greenhouse. Acknowledgement, this paper is based on work supported by Science, Technology, and Innovation Funding Authority of Egypt, grant number 30771, and the British Council of the United Kingdom, through project titled A Novel Stand-Alone Solar Driven Agriculture Greenhouse Desalination System that grows in energy and irrigation water via a Newton Musharrafa funding scheme. Thank you for attention. Thank you very much.